In this question, it is given that a bar made up of two cross sections, one of steel and other of aluminium, is shown in figure. The bar is acted upon by a compressive force P. We have to determine the value of P if the total decrease in length of the bar is 0.3 mm. The modulus of elasticity of the steel is given 205 gigapascal and modulus of elasticity of the aluminium is 75 gigapascal. So this is a question of bars of varying cross-section areas in which we are given with two different materials and different cross-section areas, aluminium and steel. The lengths are given of both the materials, cross-section areas are also given, and a load of compressive load of P is applied, and also it is given that there is decrease in length of 0.3 millimeter of this bar, and we have to find the value of P. What is the load applied to this bar? So let us solve this question. In this numerical, we are given with a bar made of two materials, steel and aluminium, and the dimensions are given. The area is given 30 by 30 and area of aluminium is given 60 by 60. Length is also given, and we have applied a compressive load P. We have applied a compressive load P to this bar. We have to find out if the total extension in the bar, is limited to 0.3 mm. What is the load applied? This we have to find out. Also, the modulus of elasticity of the steel, this material, and modulus of elasticity of the aluminium, this material, is given. So we have to find out the load, what load we have applied. So it is a problem of simple stresses. We can again apply these formulas, that change in length, whether it is tensile or compressive. So change in length of the bar is given by PL upon AE. So we can apply this formula directly. So let us do it. Let us name this 1 and 2. Let us name steel, give name steel to 1 and aluminium name it 2, right? So total deformation in the bar is given by deformation in steel plus deformation in aluminium. Change in length of steel plus change in length of the aluminium. So delta L given as P, load is same in steel and aluminium, PL upon A, area is different, E is also different. So we have written E1 here, plus both are compressive, so we are adding this P L2 upon A2 E2, right? And this is decrease in dimensions. This must decrease in dimensions, right? So delta L will be equal to P. P we have to calculate, and delta L is given. So delta L is given now. How much is it given? 0.3 mm. So 0.3. We are writing here mm, millimeter. So in the formula also we will use the length dimensions as millimeter, right? Others we will use the SI unit. So 0.3 millimeter we are using. So P we have to calculate. We don't know the value of P. L1 is 600, and we are writing millimeter because here we are taking millimeter. So 600. Now area, other things in SI unit. Area is 30 by 30 millimeter square. So we have to convert it into meter square. So 30 multiplied by 30 millimeter converted into meter, multiplied by E, steel has 205 gigapascal of modulus of elasticity. So this is our first value, P multiplied by its length 600. So this is the first term, this term we have written, right? And the answer will come in Newton now, right? The force will come in Newton now, because millimeter will cancel out, other things are SI unit. So Newton will be the answer, plus P multiplied by length L2 800 mm divided by area 60 by 60 millimeter square converted into meter square. So you have to multiply it by -6, 10 power -6, and E2 is aluminium 75 gigapascal, 10 power 9. So this is our equation. Now here, how many unknowns are there? Only one unknown. What is the unknown? P. Other things are known. It can be solved very easily. So try to solve it. take your time, use calculator and solve it, and then I am writing the final result, right? So P will come out to be, when you calculate it, because this is only one unknown here, so 48 point, you will get 48.27, this much kilonewton. You will get the answer in Newton, but I am writing in kilonewton, so convert that into kilonewton and you will get the answer. So this is the answer of this question.